Hello friends, in this session we will be discussing about the basic structure of BLDC motor along with its advantages. Let's begin. Yes, so now speaking about BLDC motor, let us try to understand what is the meaning of BLDC first. See here. What do we mean by BLDC? BLDC in the sense this BL indicates brushless. DC is nothing but DC only and it is motor. Now, what is the meaning of brushless DC motor? Brushless DC motor means in this particular BLDC motor structure, there will not be any brushes. How? See here. If there will be no brushes, see here, because we have already talked about DC motor applications, DC motor stuff, right? In case of DC motor, if you see, what is there? We are going to have commutator, right? And we are going to have brushes. This is what we have in case of a DC motor, right? But in case of a BLDC motor, both these things will not be there. Not be there in the sense, this operation, whatever this feature was there in case of DC motor, that particular feature will be now done by something called as electronic commutation. This is what happens in BLDC. How it happens, what it happens, we will see later. Don't think about it much. For time being, if you see, commutator and brushes stuff will be replaced by electronic commutation. How it is done, where it is done, I will tell you. Believe me. Anyways, let us think of, see here. If you think of the construction means, see, basically what is a BLDC motor? BLDC motor is nothing but a three-phase synchronous motor only, whose rotor is a permanent magnet. How? Let us see. See here. Basically, if you see, this is nothing but a AC motor plus combination of AC motor plus solid state inverter and rotor position center. Rotor position sensor. So if you think of BLDC motor is a complete mixture of all of these three things. How are they happening? I will tell you right now. See here. What is the meaning and why do we actually need those stuff? See. What is the meaning of solid state inverter? Solid state inverter in the sense, see, we have already talked about it in a subject called as power electronics. No need to discuss about it much in case of machine, right? If you think of this one, solid state inverter, either you can form this by using a transistor circuit, or you can use thyristor circuit, right? Thyristor in the sense SCR, silicon controlled rectifier circuit. Now if you see here, in case of transistor, or if you think of thyristor, this transistor which is there, this transistor circuit means solid state inverter having transistor circuit is actually present in case of low power applications, means low power BLDC drives. and thyristor based circuit is used for high power. High power BLDC drives. Now you may ask me, sir, but thyristor for high power, transistor for this one. Why do we need that? See here, because if you think of transistor, it is electronic element, small element. So its operating capacity is going to be very, very less. Its power handling capacity which is there, it is very less. Whereas in case of thyristor, if you see this thyristor or SCR, if you think of, it is basically nothing but power electronic device. In the sense, what do you mean by this? The name itself says that it is power. Means it can be used for high power application. What is that? You may see that in some another subject called as power electronics. Anyways, now you please see here, this was about this inverter stuff, right? Now, what is this rotor position center? See, sensor. See, this one, rotor position sensor. Rotor position sensor which is there, it is used for what purposes? Let us see. It itself says that it is going to sense the position of rotor, means it is going to sense position and speed of motor, or we can say speed of rotor, because rotor is something that is always rotating, right? So it is going to sense the speed and position of rotor, and depending on the application, means depending on the load, it will actually tell us. Anyways, if you think of sense position rotor, for this particular purpose, what we have is rather something called as Hall effect sensors. We use Hall effect sensors, or we also use, or we can say, and we also use something called as, and we also use electro-optical sensors. Getting my point, right? Either Hall effect sensors or this one, electro-optical sensors. If you think of electro-optical sensors, these electro-optical sensors, this particular electro-optical sensors, inside them they have three stuffs. What is that? It has something called as LED, light emitting diode. And you have shaft mounted slotted wheel. What is that? We will see later. And along with that, at last what we have is phototransistor. Now see, here is the thing, you need to interconnect all the subjects. If you think of these things, this LED, shaft mounted soft wheel, etc., those things will be basically taught, or you must have already learnt about them in a subject called as measurements. You must have learned them in measurements, or EEM we say, electrical and electronic measurements and sensors. There you may have seen those transducers and all stuff like that, right? Anyway, so if you think of, this is the whole structure. Now let us think of this AC motor. Now you may say, sir, but how? See here, rotor position sensor, it will sense the stuff, sense the speed of the rotor. At the same time, it is going to sense the position of the rotor, right? Now if you think of, when it is sensing them, it is, and through some sensors, right? Hall effect sensors and all. So these sensors will be producing some electrical signals. Right? And these electrical signals will be fed back. These electrical signals given by these Hall effect sensors and electro-optical sensors, these electrical signals will be given to the switches of this solid state inverter. So that sequence, switches of, how it is happening, I will tell you. You please don't worry about it. Switches of this one, switches of this electronic commutation. Alright? Switches of this particular inverter, or we can say structure which is used. Either it is a transistor structure or it is a thyristor structure. Doesn't matter to us for operating principle point of view. Anyways, if you think of, then let us think of this AC motor. We have talked a lot about this inverter as well as that sensor. Now, let us think of AC. Yes, you may feel that, sir, but why we have to have this particular sensor? You will understand that gradually. Don't worry. Anyways, let us speak of this AC motor. If you think of this AC motor, if you see, we have already talked about, stator is going to be what? Stator has what? 3-phase armature. Definitely. Right? 3-phase armature. And on the rotor, what we have? We are going to have, what we have there? There we are going to have field. Then you ask me, sir, but synchronous also we have studied the same thing, right? But then see here, this field which is there in the rotor, this field is going to be permanent magnet. Means rotor will be a permanent magnet. This is very important thing. Rotor is going to be a permanent magnet, whereas stator is going to be simply 3-phase armature only. How it is there, we have already talked a lot about it, about that armature, right? So this is the whole structure. Now if you just see what happens in actual DC machine, actual DC machine in the sense our ancestors times DC machine, means conventional DC machines. In conventional DC machine, what we have there, if you see what we have on the stator, we have field, right? Whereas on the rotor, we have armature, right? Now if you just see here, in case of ancestors DC motor, our old syllabus DC motor, if you see, syllabus in the sense old DC motor, if you see, stator used to be on field, whereas in case of BLDC motor, which is new advancement, invention, if you see, we are going to have field on the rotor is going to have the field, whereas in case of our previous motor, we used to have armature on the rotor, whereas now what are we going to have? We are going to have armature on the stator. So things are what? Reversed in the sense, this is the reason we call that BLDC motor is also a inside out motor. So we call it as inside out motor. BLDC motor also called as inside out motor. For you, what is important? You just need to understand this point, that the stator is going to have armature and this field is going to have, or the rotor is going to have permanent magnet. We will talk about it gradually, don't worry. Anyway, see here. Now, yes. See. Let us try to define some classifications. What are the different types? Classifications of DC motor. See here, basically if you think of, classification can be done on the basis of two things. One is the structure and other is going to be the control scheme. Control scheme in the sense here, see, because if you see here, yes, so now you may ask me, what do we mean by scheme of control? Scheme of control in the sense, see here, means if you think of this sensor, these sensors are basically nothing but transducers only, right? Those will sense the speed of rotation, right? And then convert it into electrical signal. That particular electrical signal will be taken back here, which means this is going to form a feedback loop. Why we need to have sensors, we will see, don't worry about it, but just keep in mind for time being that yes, we have something called a sensor. Sensors will have some electrical output and that output will be taken back in order to give the feedback, and this is going to complete the feedback loop. Feedback loop in the sense, definitely there has to be controlling scheme, control mechanism, right? So depending on that particular also, we are going to have the different types of BLDC motor. So now if you think of here, see, let us think of structure point of view. Structure point of view, if you see, there are two types. What's here? In runner BLDC motor and out runner BLDC motor. What happens in them? Let us see. In runner in the sense, see, in runner means what? I will explain. Let me have a stator first. Let us have our beautiful stator. As always, we have this, right? Let me have this, let us say this A dash, because it is three phase only, right? A dash. Then after 120 degrees displacement, we are going to have B dash. Everything we have studied a lot about it, right? Anyways, this is C and this is going to be C dash. Am I right? This is going to be a stator structure, right? Now, if the rotor, because see here, what is the meaning of runner? Running. Runner means running. Who is there? Who is running? Who is running? Rotor is running. Right? Now, what is the meaning of in? Because the rotor is running. So, in means what? Inside something it is going to run, which means inside this I am going to have rotor. So, here I am going to have rotor inside it. And then is inside this. Am I right? This is going to be the rotor inside it. NNS poles. By the way, these are permanent magnet rotor. Remember this. This is a permanent magnet rotor. Please remember this. Don't ever forget it. So this is the thing. Now, see, on this shaft, if you see, definitely on this shaft, there is going to be a Hall effect sensor. There is going to be some sensor. What sensor it is doesn't matter to us, because instrumentation people will take care about it. For us, machine is important. Focus on machine. Anyways, this is going to be in runner. Similarly, what do you mean by out runner, sir? Let us see. Out runner in the sense, you have the stator, right? You have the stator and you are going to have the coils A dash. After 120 degrees, B dash. Again after 120 degrees, C and C dash. Definitely, right? C dash, right? Now, if you think of outrunner indicates what? Runner is nothing but rotor, already we have discussed. Outrunner in the sense, it is going to be outside of the thing. So, this structure, if you see, that is going to be something like this. If you see, something like this, the structure is going to be there. This is going to be the rotor. NNS. Outrunner type means basically this whole thing will be mounted on this shaft. Means rotor is going to be mounted on this shaft, and inside that rotor we are going to have stator. Now how it is operating we will see later, but this is the structure, constructional part. So this is in runner and this is going to be out runner. By the way, again this N and S poles are again going to be permanent magnets, we already know. Now let us think of, see, what is the meaning of control schemes. Control scheme, if you see, we are going to have three types basically. First is going to be three phase, three pulse, 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 or we can also say it as half wave BLDC motor. That is the first type, depending on the scheme of control. Another type is going to be microprocessor or DSP based control scheme. And the next one is going to be sensorless control. These are going to be the different types. With advancements in our engineering, we can also have even more types of control schemes. Let's see that in our future. By the way, now let us try to understand what are the different advantages, because in case of BLDC motor, you don't have what things, you don't have brushes and commutators. So what is the advantage of it? Let us try to see. See here. Yes, so now let us think of advantages. See here. Advantages, see here. The first advantage is that when you have no brushes, which means, and no commutators, plus no commutators, right? When you don't have this stuff, if you see in case of DC motor, we have already talked about them, that because of brushes and because of commutators, what is happening? You need constant maintenance. So because of this, when they are not there, which means you are going to have less maintenance of the machine. This is the first advantage. Then other advantage related to the same thing is going to be what? In case of, if you see here, if you try to rotate it at some higher speeds, right? If you think of conventional DC motor, if you try to rotate it at some higher speeds, then what is going to happen? Definitely some sparking is going to happen at the brushes. Sparking at brushes is going to happen. So if you see, there is no brushes, in the sense no sparking problem. Now what is, see here, whenever sparking happens, what happens is its life reduces, or we can say it is going to damage easily. What is going to damage easily? Brushes get damaged easily, which means what we need to do here, see, sparking and brushes, right? So this is the reason these one are going to have longer lifespan. This is another advantage related to that, right? Now next advantage is what? Whatever problems we had related to electromagnetic waves and So whatever problems we had related to electromagnetic waves and radio frequencies are minimized. What were those problems, sir? We have already talked about them in case of DC motor. Here our focus is BLDC advantages. So in case of BLDC, such problems related to electromagnetic waves and all stuff like that is going to be minimized. Now if you think of the next advantage is going to be what? Torque is more. Torque is more. For the same speed in case of DC motor and in case of BLDC motor. For the same speed, if you see, here the torque is going to be more. Then again, the next point is going to be what? Power handling capacity. Power handling capacity. Power handling capacity. Definitely it is going to be more than DC. Definitely. Now, what about efficiency, sir? Efficiency is also one important parameter, right? So if you think of efficiency, what is efficiency? Efficiency of a BLDC motor is also more as compared to this. Means for example, efficiency in the sense simple. If you give 100 watt of this thing, if for example this is BLDC motor, let us say this is DC motor, right? So in case of BLDC motor, or let us think of DC motor first. In case of DC motor, if you give input, let us say 100 watt, 100 watt, then you may get somewhere around 70 watt, right? Which means output upon input, if you see, efficiency is going to be somewhere around 70%. For different motors, it will change, but somewhere around 70, 60, 65% it will be there. Why? Because of the power absorbed by the brushes going to be reduced, right? And so if you think of, but in case of BLDC motor, if for example your input is let us say 100 watt, then output power may be somewhere around 95 watt. There is no problem. Somewhere around 95 watt, 98 watt or something sort of. So if you think of, in case of BLDC motor, the efficiency is also going to be increased. Now see here, and one more point. If you see, longer lifespan indicates that, because since there are no commutators and no brushes, what is going to happen? Wear and tear is going to be less. So we need to write that point also, that yes, wear and tear is going to be less. Wear and tear is going to be less. So you may say, sir, all are advantages only, right? All are advantages only. Are there any disadvantages? Yes, definitely. Nothing is either black or this thing. Means, let me tell you, let me just give a small story, small example. Nothing in life, if you see, nothing in life cannot be completely black, and it cannot be completely white also. Because if you see, even the black and this, if you see, they are all shades of gray. They are all, always remember that in personal, in your life also, if you see, all are shades of gray. All are going to be shades of gray. In a sense, dark shade of gray will give you black. Light shade of gray will give you, right, white color. Anyways, let us come back to our point. So definitely disadvantages are there. Let us try to talk about them. Yes. Yes. So now let us think of disadvantages. The first disadvantage for this is going to be the permanent magnet. See, the operation and all, we will talk about it, don't worry. But for time being, focus on this. First thing is the permanent magnet. Right? Permanent magnet. The permanent magnet used here is of highest quality, purest quality, not like Chinese stuff. China item is not going to be used. There, the permanent magnet which is used is going to be high quality magnet. Why? Because you need high torque and high speeds. That is the reason the permanent magnet is going to be of high quality. Quality is going to be great. Right? So if the quality is more, it means that it is going to be expensive. This is the first drawback. Right? Yes. Now the second disadvantage that we have is, for that let me come back. Yes. If you think of this one, if you see electrical signal, right? See this one. You are going to have some sensor, right? That sensor output fed back to the system. What do you think about this system? Is it very easy? No. In order to design this system, you have to use some complicated programs, complicated electronic stuff. That is the reason this particular drive circuitry, or we can say this complete drive circuitry, is basically complicated. This is the second disadvantage. How it is complicated, we will see that later. Second is what? Drive circuitry is complicated. Anyway, so this was regarding the structure of BLDC motor, classification, and about its advantages and disadvantages. Now, after this, we will be talking about operating principle of the BLDC motor. Alright. Thank you so much.